Hello, everybody. I'm presenting Berlin today, and we call it Chimera Berlin. A chimera is a hybrid in biology of two species, two animals. And that's exactly what we want to achieve. We want to achieve a hybrid of premium individual and collective mobility. So how do we want to do that? Our starting point is Berlin TXL, the former Berlin airport. And as soon as it will be closed down, this will be a huge science and technology park for the future cities. And you see it's actually located about 8 kilometers away from the center of Berlin. And that's exactly our challenge. So if you look here, up there, this is TXL, Tegel, and we want to connect it to the city. And always when we try to approach a field to point or a point to field connectivity, we usually resort to either alternating mobility models, which means I choose different mobility concepts on different days, or we use the multimodal one. Let's say in the morning you start, get into your Audi, you drive, then you take the subway because it's maybe a traffic jam, and then eventually for the last mile you take your bike. Now, what you see below here is actually not the night sky of Berlin, but it's a Foursquare map. What is Foursquare? Foursquare is an application on your phone where people actually log into their destinations. So let's say they come to the airport, they say to their friends, to their peers, I just arrived in Berlin. Now imagine all these data, all these destinations you see here, we would not only see afterwards, but we knew them before. Imagine what this would make possible actually, because we could actually enable automated driving. The good news is automated driving and automated vehicles already exist in pretty much all our big cities. We see them here. Elevators are automated vehicles. They just go vertically. Now, what can we learn from elevators? And not only from elevators, what can we also learn from nature? This is not a Photoshop collage. These goats are actually really climbing up the tree to eat from the leaves of this tree. And that's exactly what we do. We are an interdisciplinary team. We are composed of Dr. Paul Friedli, who's actually the head of innovation at Schindler Aufzüge, and he's the inventor of the destination control system in elevators. Then it's Max Schwitaler, the urban planner, who actually specializes in mobility, and it's myself, I'm a neuroscientist and a biomimicry expert. And now, since you probably don't know much about biomimicry, we want to explore this a little bit, and I take you on a small expedition into my world. Before we do so, before we go into nature, I just want to show you the public traffic system of Berlin. And all the lines converge in the middle. Now, just for comparison, I show you here the map of London. Same scale, and you see they are not so much different. Again, you have lines all merging in the middle. Now, the third one I brought you, what do you think? Which city is that? Just randomly, just shout, Paris. Well, I have to disappoint you. That's actually a neuron in our brain. And they are strikingly similar. Now, the scales of dimension, of size, are remarkably different, and the speeds are, of course, amazingly different as well. But what can we learn from these systems? How are they so efficient, and how can we transfer this knowledge into our world? And that's exactly what biomimicry does. It tries to look into 3.8 billion years of benchmarking, if you wish, and learn from evolution. And 3.8 billion years is really a large time frame. We cannot really comprehend this. And our Earth is even older. It's 4.5 billion years old. So now let's compress this into 12 months. We all have an understanding what 1 year is. And if we do that, of course, on day 1, we would have the start of existence of our Earth. And then on 25th of February, we would have the first life on our planet. On 28th of March, we would have the photosynthesis for the first time. 17th of September, sex. No romantic fantasies, really simple organisms at this stage. 20th of November, fish occurred for the first time. 22nd of November, we had the plants on our planet. 24th of November, insects. 13th of December, which is on the last month, we only have the first mammals occurring. Christmas was really a bad time for the dinosaurs. They went extinct then. And we all know how long ago that actually is. And the first human-like creatures on our planet started to come on our planet or get into existence just on the last day, 11:30. And the Homo sapiens, the modern human, just exists for less than half an hour, actually. And we all pride ourselves with the invention of the wheel. That's really only 43 seconds old. Now, The question is, are we really the inventors of the wheel? And that's something I want to challenge. And I show you a video in 1 second which shows you a spider, the golden wheel spider, which actually invented the wheel way before us. This spider lives in the Sahara Desert, and it rolls down the desert dunes to escape its predator, a wasp. And let's have a look at this. So this should be...
They see me rolling, they hating, patrolling and trying to catch me riding dirty, trying to catch me riding dirty, trying to catch me riding dirty, trying to catch me riding dirty.
There we go, the spider. So this spider, unfortunately we have, oh, there it goes again, no.
They see me rolling.
I see it here, I can turn around the screen.
Patrolling and trying to catch me riding dirty, 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 trying to catch me riding dirty.
So this spider actually spins with about 44 revolutions per second, which equals a car driving with more than 300 kilometers an hour. So we are really not necessarily the inventor of the wheel. So what can we learn from nature? And what I just wanted to show you, because biomimicry is an emerging discipline, which is now can be seen in many fields and sectors. This is the Shinkansen train in Japan, in Tokyo. It's a high-speed train. And it was also called the bullet train. Why is that? Because whenever it left the tunnel, it made a big bang, just because it compressed the air and the air was released. Now, the residents didn't like this, clearly. So the engineer was asked, please solve this problem. And by chance, he happened to be a specialist in birds, just in his free time. And he knew that the kingfisher, with his beak, was able to dive into water without splashes. Now, this is the same concept, right? From a low-density medium and a high-density medium. So they transformed this structure of the train into a very nosy structure, and suddenly the problem was solved. There was no bang. The train saved 10% energy, and it could go even faster. So there's a huge potential in that, and that's what biomimicry is about. Now, our approach to the Audi Urban Future Award is to ask what moves where and how. And what means, what are the vehicles of our future? How do they look like? How do they function? Where refers to the infrastructure. Where do they actually move? And eventually, the how refers to how do the cars, the vehicles, interact with each other, but also with the built environment and the people. Now, let me give you a few examples of how we approach this. First, let's focus on the what and where. And what you see here is skin. All our skin, it consists of hundreds and thousands of cells. And each individual cell actually has these protein networks in the cell. And they are the so-called microtubules. These are structures which hold the cell in place, but they also serve as roads to transport proteins along the cell. Now, why is this important, and what is interesting about this? What you see here, this big cable, that's actually one of these roads, and the protein, basically the powertrain, the prime mover, is specific for this road, just like our cars. But what's interesting is that the capsule, the cargo, can actually be decoupled, because there can be different cargo on a prime mover. And that led us to an idea, why couldn't we uncouple the prime mover from the actual passenger cabin? Why is that interesting? Because you can customize the cabin at the same time. A separated prime mover may allow us to drive on different infrastructures, be it road, hijack maybe the public transport system, or else. A second idea is, and it comes from the ants, how do we deal with data? And how do we interact and communicate? Now, let me tell you something about the ants. Ants communicate via a concept called stigmergy. What is stigmergy? The ants do not communicate directly from individual to individual, but they leave a pheromone trail, something that smells and is basically an environmental cue for the next individual. Now, the thing is, if the next individual, the next ant comes, it reinforces that, but if there's no ant, the signal disappears over time, it vanishes. Now, if we go back to our four-square map, these traces, these destinations will remain forever. We don't need them forever. We need them at the right point in time and to predict things, of course, in advance. But we do not need to track them back to the individual user. Now, how can we transfer this back to our mobility and destination control? And that was the little exploration into nature, and to tackle this and to use this insight to really shape a novel idea for the Audi Urban Future Award. That's exactly why we have this three team parts within our team. And with the knowledge of the destination control, this can actually be possible and allow for autonomous driving. We are the Berlin team. We come from a city which is not particularly famous for actually opening new airports. But, and that's the good news, we are pretty good at actually transforming airports, which will be closed soon, into cities of the future. Thank you very much.
Thank you very much, Arne Pechstein.